Hello again, dear grade 9 students. Today we will learn about another type of voltages called AC voltage. At the end of this video, you will be able to differentiate between AC and DC voltages, differentiate between AC and variable voltage, and at last, list the different form shapes of AC voltage. Let's first of all recall the role of the oscilloscope. What is the role of the oscilloscope? It allows us to measure and visualize the voltage. What are the two terminals of the oscilloscope? It has two terminals, the phase and the ground. How are these two terminals connected? The phase is connected to the positive pole of the drisel and the ground to the negative pole of the drisel. To facilitate memorization, the phase starting with the letter P should be connected to the positive pole starting also with the letter P. Isn't that a good idea? How is the DC voltage displayed on the screen when the sweeping is on? As a luminous horizontal line. Name a source of DC voltage. We have, for example, the drisel. Let's also recall the parts of the oscilloscope. This is the screen of the oscilloscope. The two luminous signals are called the oscillograms. This is the positive part of the screen, while this one is called the negative part. Each square on this grid is called a division. Each division is made up of 5 subdivisions, where each subdivision represents 0.2 divisions. Here we have the two poles of the oscilloscope. This one is the phase pole, while this one is called the ground pole. And these are the two sensitivity buttons. This one is called the time-based button, while this one is called the vertical sensitivity button. Now we want to focus on these two buttons. So here we have the vertical sensitivity button. Its unit is volt per division. It corresponds to the vertical scale of the oscillogram. This means that every vertical division holds an amount of voltage. And this button is called the time-based button. Its unit is milliseconds per division. It corresponds to the horizontal scale of the oscillogram, which means that every horizontal square holds an amount of time. Now please do this application along with me. What do the two values on the screen indicate? The horizontal division holds 20 milliseconds while the vertical division holds 10 volt. So the 20 millisecond indicates the time-based VB or the horizontal sensitivity SH, or we can say that VB is equal to 20 milliseconds per divisions. Now the 10 volt indicates the vertical sensitivity SV or the vertical amplitude gain, or we can say that SV is equal to 10 volt per division. We have often mentioned the two terms AC and DC. What's the difference between them? Electricity or current flows in two ways, either in an alternating current AC or in a direct current DC. Electricity or current is nothing but the movement of the electrons through a conductor like a wire. The difference between AC and DC lies in the direction in which the electrons flow. In DC, the electrons flow steadily in a single direction or forward, from the negative pole of the drisel to the positive pole, while in AC, electrons keep switching directions, sometimes going forward and then going backward. This photo shows how the electrons keep switching directions. Sometimes they go forward and other times they go backward. Now, how are DC and AC voltages represented on the screen of the oscilloscope? In DC voltage, the voltage appears as a horizontal luminous line, while in AC it appears as a luminous signal. Now, what's the difference between DC and AC voltages? Here we have some type of voltages. This voltage keeps constant as the time varies, so it is called the DC voltage, which remains constant with time, while this one, it varies as the time varies, so it is called the variable voltage, while this one is called the alternating periodic voltage, since it alternates successively between positive and negative values. Now match each oscillogram with its corresponding voltage. This voltage alternates successively between positive and negative values. This one varies as time varies, while this one keeps constant as the time varies. So we match the first one with AC voltage. This is the variable voltage, and this one is called DC voltage. Now, how do the oscillograms appear on the screen of the oscilloscope in the case of AC voltage? In the first case, in the absence of the voltage, and when the sweeping is off, or when the VB button is adjusted on the zero level, a luminous spot appears at the center of the screen. But when we sweep on the oscilloscope, the luminous spot starts to move on the x-axis and accelerates until it appears as a horizontal luminous line. So, in the absence of the voltage and when the sweeping is off, a luminous spot is observed at the center of the screen. But when the sweeping is on, a horizontal luminous line is observed at the center of the screen. Now, in the presence of the voltage and when the sweeping is off, or when the VB button is adjusted on the zero level, a luminous vertical line appears on the vertical axis. This vertical line becomes longer and longer as the vertical sensitivity decreases. So, when the sweeping is off, a luminous line is observed on the vertical axis. Now, when the sweeping is on, a luminous wave appears on the screen. This wave changes its height and its number of cycles as the SV and the VB sensitivities change. We will discover this later on. So, when the sweeping is on, a waveform is observed. Now, what are the types of the AC voltage? We have four types of AC voltage. The first one is the alternating sinusoidal signal. This one is called the square signal. This one is called a triangular signal. And also we have the bicycle signal. So this is the alternating sinusoidal signal. This is the square signal. This is the bicycle signal, and this one is called the triangular signal. In fact, each name is given according to the shape of the signal. To sum up, we have two types of voltages. The DC voltage is the constant voltage which does not change with time, and the AC voltage is the alternating voltage which alternates successively in a periodic manner between positive and negative values. In the absence of AC voltage, when the sweeping is off, a luminous spot is observed at the center of the screen. When the sweeping is on, a horizontal luminous line is observed at the center of the screen. But in the presence of AC voltage and when the sweeping is off, a luminous vertical line appears on the vertical axis, while when the sweeping is on, a waveform signal is observed. And finally comes the assignment. Please solve the applications again, memorize the summing up, solve exercise 7, page 79-80 on your book. Thanks for watching us and have a nice day.